Mike Hathaway, and my restoration project takes place at the Nisqually Upland Forest within the Billy Frank Jr. Nisqually National Wildlife Refuge. The refuge is located in Olympia, Washington, and is managed by the U.S. Department of Fish and Wildlife. It was established in 1974 and in total encompasses 4,529 acres. The map on the right shows the refuge boundaries in blue and my restoration site marked with the black pin towards the left side of the map. Now, this is a zoomed out view of Washington looking at the Nisqually River watershed. The Nisqually River headwaters start within Mount Rainier National Park, and it runs for 78 river miles to the outlet into Puget Sound inside the Billy Frank Jr. National Wildlife Refuge. One neat thing about the Nisqually River is that both the headwaters and the estuary, the river delta, are both on federally protected land. So like many restoration sites within the US, mine too has felt the effects of urban development. And here is showing a time lapse from 1984 through 2025 of my site and the Nisqually Wildlife Refuge, as well as the urban development around Olympia, Washington. So you can see the site was clear cut, and while the rest of the town has been built up very rapidly, the site has stayed vacant. So now focusing back in on the National Wildlife Refuge, in the left side of the image you can see the shaded yellow area, and that's my proposed project site. That area was clear cut to be a housing development in 1989. The development fell through and it was left vacant for a few years and then was acquired by the refuge in the mid-90s. And that total site is just about 40 acres, and it's been sitting vacant ever since. At the bottom of the image, which is the west side of the project site, is Meridian Drive, and that runs parallel to the project site. The rest of the image is what I'm focusing on, and you can kind of make out two polygons in the center of the project area where there's some larger trees. And those are leftover trees from the early 90s that the refuge planted with success and today are still thriving and on average are about 40 feet tall. And everything else that they have tried to plant at this site has failed. And there was a time when this whole area in yellow was all trees, all planted trees. And the only ones to survive are the two smaller polygons at the bottom of the image. The site description for this project area is a Puget lowland with an elevation of 236 feet. The native vegetation is a mixed conifer forest, and the whole site is predominantly a slight south-facing slope, and the soil is categorized as Everett, which is gravelly glacial outwash, coarse, loose, stony, and holding little water according to the database from Cogger, which is encompassing of all Puget Sound soil profiles. Over the past 5 years, I've spent a lot of time at the site, supervising a Conservation Corps crew where we plant and maintain the planting, so I've really gotten to experience the challenges facing this site. There's no topsoil. We are trying to plant in subsoil, which is essentially rocky sand. We use rock bars to dig holes, and when we install the plants, we fill the hole with soil amendment, which seems to help initially, but it's not quite cutting it. We plant in winter, and what I've noticed is that the plants do well throughout the winter and the spring, and once summer hits, they all dry out, so there's very high mortality. We mulch around the plants to try to retain water, suppress weeds, and lower soil temperature, but to no avail. And since the 90s, this area has been infested with Scotch broom. So before we plant, we pull all the Scotch broom, and the whole 40 acres was pretty much a Scotch broom forest before we started. And soil compaction is a huge issue as well. Throughout the late 90s, 2000s, and 2010s, The refuge maintenance team was mowing the Scotch broom to keep it from seeding, so there's been a lot of heavy equipment driving around on this site. And so the plants that do survive, the ones that we do plant that make it, they're very stunted. A lot of the ones that I planted 5 years ago are still below my knee, where if they were in a more suitable habitat would be 2 to 3 times taller. My 3 main goals for this site are to rebuild soil health, manage invasives, and revegetation. The list here on the left is all the invasive species that are currently on the site, and the list on the right is all the native species that have been planted since the 90s. So there's a few native plants that are kind of scattered around that were part of the early planting in the 90s. The only ones that came in on their own that weren't planted are the black-capped raspberry and the miner's lettuce, which actually came in on a mulch delivery. Here's just some pictures of my crew doing some manual control of some noxious weeds. So on the left, they're digging out tansy ragwort, and on the right, they're pulling Scotch broom. This area typically experiences warm, dry summers with highs in the 70s and cool, wet winters with highs in the 30s. According to the Western Regional Climate Center in partnership with NOAA, the annual rainfall is around 50 inches, of which only 3.5 come during the summer. 3 attributes of a restored ecosystem will be addressed to restore this habitat, the first of which is a characteristic assemblage of species. Soil and native species are on the foundation of a healthy ecosystem and is the main focus for this restoration project. Trees and shrubs are the end goal for this site, but will not be a part of the beginning phase. Improving the soil is the first step. First thing will be to break up the soil and decrease compaction. According to Viral et al., after clear-cut logging, surface soil had lowest compaction, while soil at 15 to 40 centimeters in depth was 4 times more compacted than the surface. By improving the soil, we'll also increase the water holding capacity and create a suitable habitat for mycorrhizal networks, which simmered in 2004 showed may strongly influence seedling establishment. An assisted succession process will be implemented where fibrous plants and legume species will be introduced to help decrease compaction and increase soil fertility. The next attribute for this site will be installing indigenous species. Here's a list of indigenous species that will be used for this project. One of which is the Oregon white oak, in which Dunwoody in 2003 stated, is highly beneficial when restoring native grasslands. Now, though we're not restoring a native grassland, the process of which I'm going about this is kind of like establishing a grassland first in order to turn it into a forest. Here are some more indigenous species that will be used. The third and final attribute to be used in this restoration project will be how the physical environment can sustain populations. By shaping the environment to our needs, we can affect the outcome of our efforts. By installing swales to encourage water holding capacity and decrease water loss from quick draining soil, the installed plants will have greater access to water and nutrients. By using cover crops, we can build up organic matter over time and introduce more nutrients into our soil. The first restoration field protocol will be to begin ripping the subsoil, in which, according to Tabebu 2020, they had success ripping through the hard pan to loosen the soil. The plan would be to initially rip the soil and then lay out compost and topsoil, disc that in to incorporate it into the existing subsoil that's already on the site, and then come back through and broadcast seed cover crops in the late summer. Through Cogger's work with the Washington State University, he identified successful cover crops to improve soil quality in Washington. Listed are the cover crops that would be used, in addition to the seed manufacturing companies. The next step would be to apply wood chips over the soil, which, according to Sharon Brock, demonstrated how wood chip mulch improves the soil quality for trees growing in compacted soil. Non-winter kill cover crops will be mowed before seed production. On a 2-year timeline, we'll include managing invasive weeds by doing cut stump treatments of Scotch broom and treating with glyphosate, spraying Canada thistle, bull thistle, and tansy ragwort with aminopyrrolid, and manually pulling out and digging out other noxious weeds. After 2 years of this and cover cropping, we'll hopefully have enough soil built up to begin early successional planting, of which red alder will be planted, and according to Binkley 2003, showed how red alder can improve Douglas fir growth efficiency by enhancing soil fertility. So the end goal is a mixed conifer forest, which is predominantly Douglas fir, and so hopefully by installing red alder, we can later on introduce Douglas fir into the restoration plan. Spacing for shrubs will be 6 feet and 12 feet for trees, and shade-tolerant species such as Douglas fir and western hemlock, western red cedar will be introduced once there is less than a 25% canopy opening. An adaptive management plan will be in place in order to ensure a successful restoration for the site. Manual control on invasives will include mowing, chemical control will include herbicide treatments, and biological control is already in place for the tansy ragwort, which is the cinnabar moth. Mulching will be used for weed suppression. Plant protectors or tree tubes can be used if there is high deer browsing activity, and we can provide supplemental watering throughout the summer in case any warm or drought periods. Monitoring will include assessing plant survival twice a year, once early in summer and once before planting season early fall. Signs of success will include visible mycelium in the soil, and cover crops will be used until mycelium is present in the soil. Once present, focus will be on planting 25% shrubs and 75% trees. Photo monitoring will occur every year, and according to Evans et al. 2016, they showed how monitoring from consistent focal points can be an efficient reference point for observing the landscape over time. Annual planting site maintenance will include replanting in the winter as needed to offset mortality, mowing in the spring so the weeds don't outcompete the desired plants, applying chemical treatments to weeds resistant to manual control methods, mowing again so that the plants don't get shaded out, providing supplemental water via water trailer if needed during the summer, and installing plant protectors if deer browse is high. Here's my works cited page, and thanks for watching.